Why nothing can go faster than light. It sounds like one of those facts you hear in school, nod your head at, memorize for an exam, and then never really think about again. Like being told that gravity pulls things down, or that water boils at a certain temperature. It feels like a rule, almost like a traffic sign posted by the universe. Speed limit, light, do not exceed, end of story. But the moment you slow down and actually ask why, not how, not what the formula says, but why this limit exists at all, something very strange happens. The simple picture starts to wobble. The comfortable explanation collapses, and you realize that this speed limit is not really about light. It's about the structure of reality itself. So let's start with a child's question, a dangerous question, the kind of question that refuses to stay quiet. Why can't I just go faster? Imagine you're in a car, you press the accelerator, and the car speeds up. Press harder, it goes faster. There's no deep mystery there. More fuel, more push, more speed. If the road is straight and long enough, why shouldn't you keep going faster and faster? 1,000 kilometers per hour, 1,000,000, 1,000,000,000. At first glance, nothing seems fundamentally wrong with that idea. Faster is just faster. More effort gives more speed. That's how everyday life works. So when someone tells you that there is a hard limit, not because of engineering, not because of friction, not because of fuel, but because the universe itself refuses to allow it, your intuition should rebel. Mine certainly does. Why would the universe care how fast something moves? Is space tired? Is time fragile? Is light special because it's made of something magical? And this is where Feynman would smile, because the moment you feel confused, you are finally in the right place. Most explanations begin in the wrong way. They start by worshipping light. They say light is special, light is fundamental, light is fast. But that's not the real story. Light is not the boss here. Light is just the messenger. The real mystery is not that light moves fast. The mystery is that everything else moves slowly. Think about it. Light doesn't struggle to reach its speed. It doesn't accelerate in the usual sense. It just is. It moves the way sound moves in air, except there is no air. It moves the way ripples move on water, except there is no water. It moves because that is how the universe allows information to move. And that word, information, is where the story quietly turns. Imagine you are trying to shout across a field. Your voice carries because air molecules bump into each other, passing the vibration along. Now imagine there is no air. You can scream as hard as you like, but nothing travels, no bumps, no message. The universe is similar, except the medium is not air. The medium is space and time themselves, and they have a built-in rhythm, a maximum rate at which cause can turn into effect. Light is simply the thing that rides this rhythm perfectly. Now let's slow this down even more. Suppose you try to push an object. You put your hand on it and apply force. What happens really? Do you instantly affect the entire object? Of course not. The push travels through the material, atom by atom. Even in a solid piece of steel, the signal moves at a finite speed. Nothing responds all at once. Now extend that idea beyond materials. Extend it to space itself. If space is not just emptiness, but something with structure, then changes cannot happen everywhere instantly. They must propagate. And the speed at which they propagate is what we call the speed of light. But notice something subtle. We didn't say light causes the limit. We said the limit causes light. This is the reversal that textbooks rarely emphasize. Light is fast because the universe allows no faster way for information to move. Now you might ask, all right, but why that speed? Why not twice as fast? Or infinite? Why not allow instant effects everywhere? This is where our everyday intuition completely breaks down. We are used to thinking of time as universal, one big clock ticking for everyone. You and I agree on what now means, but the universe does not work that way, not even close. The moment you accept a finite maximum speed for information, time can no longer be absolute. Different observers must disagree on what happens first and what happens later. Otherwise, contradictions appear. This is not philosophy, it's necessity. If signals could travel infinitely fast, cause and effect would blur. Events would overlap in impossible ways. You could send messages into your own past. The idea of before and after would collapse. So the universe chooses consistency over convenience. It chooses a structure where time and space adjust themselves to preserve cause and effect. And the price of that consistency is a universal speed limit. Now let's use an analogy because this is heavy. Imagine a giant cosmic chessboard. Every move must follow rules or the game stops making sense. If pieces could teleport anywhere instantly, strategy would disappear. Cause and consequence would be meaningless. The game would dissolve into chaos. The speed of light is like the rule that says pieces move one square at a time. It's not arbitrary. It's what makes the game possible at all. Now here's where things get truly mind-bending. When you try to move faster and faster, you are not fighting light. You are fighting time itself. As you accelerate, time for you begins to behave differently compared to time for someone watching you. This is not an illusion. It's not a trick of measurement. It's the universe rearranging itself to protect its rules. Your clock slows, distances compress, not because you are doing something wrong, but because that is the only way to keep the speed of information the same for everyone. You don't hit the speed of light like a wall. You slide toward it, asymptotically, forever needing more effort for less gain. It's like trying to reach the horizon. You can walk toward it all day, but it never arrives. And again, this is not about light being stubborn. It's about reality being internally consistent. Feynman loved this part because it shows how deeply non-human the universe is. It does not care what feels reasonable to us. It cares only that its rules don't contradict themselves. Now let's take a breath and reflect. We are not saying that light is fast. We are saying that reality is slow. Slow in the sense that it refuses shortcuts. It refuses instant communication. It refuses to let the future know about the present before the present happens. This slowness is what gives the universe texture. It gives it stories. It gives it history. Without this limit, stars couldn't form properly. Atoms wouldn't behave. Life would have no stable sequence of events to unfold within. The speed of light is not an obstacle. It's a scaffold. Now imagine a universe with no speed limit. Every part of space knows instantly what every other part is doing. There is no delay, no propagation, no waiting. In such a universe, the idea of motion itself becomes meaningless. Everything happens everywhere at once. That universe sounds powerful, but it is sterile. Nothing unfolds, nothing evolves, nothing has time to become something else. Our universe, by contrast, is patient. It allows things to happen step by step. It enforces a maximum pace, and within that pace, complexity blooms. This is why Feynman would say that physics is not about answers, but about learning how to be comfortable with the way the universe refuses to match our expectations. We expect speed to be additive. Push more, go faster. The universe says no. Speed is relational. It's tied to time and space, and those are not rigid backgrounds. They are participants. We expect limits to be imposed by materials. The universe says no. The limit is woven into existence itself. We expect light to be special because it's light. The universe says no. Light is special because it has no rest state. It has no choice but to move at the maximum speed reality allows. Now let's zoom out even further. Every time you see something, that sight is delayed. You are never seeing the present. You are seeing a memory carried by light. When you look at the sun, you see it as it was minutes ago. When you look at distant stars, you see ancient history. This means the universe is not a snapshot. It's a layered story, spread across time. And that layering is only possible because nothing outruns the speed of light. If everything were instant, there would be no perspective, no distance, no story. The limit creates the stage on which the universe can perform. This is the shocking insight. Not that light is fast, but that speed itself is constrained in order for reality to exist in a coherent way. When Feynman talked about this, he didn't present it as a triumph. He presented it as a humbling reminder. We are not living in a universe designed for our intuition. We are living in a universe designed to be self-consistent, and we are lucky that it is, because within this limit, galaxies form, chemistry works, brains think, and questions like this can even be asked. So the next time someone says, nothing can go faster than light, don't hear it as a restriction. Hear it as a quiet statement about how carefully balanced reality is, and then let the deeper question linger. If the universe had chosen a different speed, would anything exist at all? And if this limit is not about light, but about causality, what else do we believe is fundamental? That is really just a consequence of deeper rules we haven't yet learned to see. That question doesn't end the lecture. It opens it. And the universe, as always, remains silent. Not because it has no answer, but because it expects us to keep asking. And once you really accept that nothing can go faster than light, another strange realization quietly appears. It's not loud. It doesn't announce itself. It just sits there, waiting for you to notice it. Motion itself is not what you thought it was. We grow up thinking that speed is something you have, like height or weight. You are fast. I am slow. This car is quicker than that one. It feels like an absolute property. But the universe doesn't see it that way at all. In fact, the universe doesn't care how fast you think you're going. Imagine you're sitting on a train, smoothly gliding along. You toss a ball straight up, it comes back down into your hand. Perfectly normal. Now imagine someone standing outside, watching the train pass by. They see the ball tracing a curved path through space. Same ball, same toss. Two completely different descriptions. Which one is correct? The uncomfortable answer is both. Speed only exists relative to something else. There is no universal background that says this is true rest, no master reference frame, no cosmic stillness. And light exposes this fact mercilessly. No matter how fast you chase light, no matter how fast you're already moving, light always moves away from you at the same speed. That should feel impossible. It should feel like cheating. If you run after a car, it looks slower relative to you. If you run after sound, it changes. But light refuses to play along, and the universe responds to this refusal by doing something radical. It changes space and time instead. This is where people often say that can't be real, and yet it is. Time slows down, lengths shrink, not because something is broken, but because these adjustments are the only way to keep the speed of information consistent for everyone. The universe is not flexible about causality. Everything else must bend. Now think about how strange that is. We assumed space was a passive stage, time was a ticking clock, and things simply moved around inside them. But light forces us to abandon that picture completely. Space and time are not the stage. They are part of the performance. They stretch, compress, and rearrange themselves to protect the rule that cause comes before effect. This is why trying to go faster than light is not like breaking a rule. It's like trying to step outside the logic of the universe. It's not forbidden because it's dangerous. It's forbidden because it doesn't make sense. Now let's slow down again, because this deserves patience. Imagine you're reading a book. Page 1 comes before page 2. If suddenly page 50 could influence page 10, the story would collapse. The book would no longer be readable. The speed of light is what keeps the universe readable. Events unfold in an order. Signals take time. Information moves step by step. And because of that, the universe has a narrative. Without this limit, reality would be a scrambled mess of simultaneous contradictions. And here's the part that usually gets overlooked. The speed limit doesn't just affect rockets and particles. It affects you. Every thought you have, every nerve signal in your body, every memory forming in your brain obeys this limit. You are a slow creature in a slow universe. Your conscio. Usness exists because information does not arrive all at once. Now think about that for a moment. If information were instant, there would be no process, no build-up, no anticipation, no awareness unfolding over time. Experience itself depends on delay. So when people say the speed of light is a restriction, I always want to ask, restriction from what? From chaos? The universe is not holding us back. It is holding itself together. Feynman loved to point out that when we finally understand a rule of nature, it usually turns out to be simpler and more ruthless than we expected. The speed of light is not polite. It does not negotiate. It does not care how clever you are. It simply says, this is how fast reality can talk to itself, and everything else must adapt. Now let's go even deeper, because the real shock is still waiting. When you move faster, you don't just approach the speed of light. You approach a boundary where time itself starts to lose meaning. At that boundary, time for you slows to a crawl compared to the outside world. From your perspective, nothing seems wrong. Your heart beats normally. Your thoughts feel ordinary. But to someone watching you, you begin to freeze. This is not metaphorical. This is real. At the speed of light, time stops. And that single statement should make you uneasy, because it means that light does not experience time the way we do. From light's point of view, if we can even say such a thing, emission and absorption happen together. No delay, no journey. Which means light is not just fast. It lives in a different relationship with time. And this tells us something profound. The speed of light is not just a speed. It's a boundary between different ways of existing. Below it, things age. They change. They experience before and after. At it, time collapses. Above it, the concept breaks entirely. This is why going faster than light isn't just hard. It's undefined. And whenever physics tells you something is undefined, it's not being lazy. It's telling you that your question no longer fits inside reality's language. Feynman would often say that nature doesn't allow paradoxes. If a question leads to contradiction, it's the question that's wrong. So maybe the right way to think about this is not why can't we go faster than light, but why does the universe require a maximum speed at all? And the answer keeps circling back to the same quiet truth. Because without it, nothing could be ordered, nothing could be stable, nothing could be experienced. The speed of light is the stitching that holds the fabric of space-time together. And here's the most unsettling part. We didn't discover this because we wanted to. We discovered it because experiments forced us to. The universe backed us into a corner and said, either accept this or give up on understanding anything. That's not comforting. But it is beautiful, because it means reality is not arbitrary. It has a structure. And we are slowly, painfully learning how to listen to it. In the final part, we'll step back even further and ask the question that Feynman always left hanging. If the speed of light shapes time, space, causality, and experience itself, what does that say about the limits of human intuition? And what other rules are we still mistaking for mere facts, when they are actually the deep grammar of existence? That's where this really gets uncomfortable. And now we arrive at the strangest part of all, the part that doesn't fit neatly into physics, or philosophy, or everyday language. The part that stays with you long after the lecture ends. If nothing can go faster than light, and if this limit shapes time, space, causality, and even experience itself, then what we call common sense is not a guide to reality at all. It's just a survival tool, tuned for slow speeds and small distances. Our intuition evolved in a world where delays are tiny, where cause and effect feel immediate, where time seems universal and solid. We never evolved to feel the speed of light. We only notice it when it breaks our expectations. This is why these ideas feel disturbing. They are not wrong, they are unfamiliar. Feynman used to say that the problem is not that nature is weird. The problem is that we insist on imagining it as familiar. The universe does not care how something feels to us. It cares only that its rules remain consistent. And when we push against those rules, reality doesn't argue, it simply refuses to cooperate. Think about how humbling that is. We can build machines that leave the planet. We can split atoms. We can detect whispers from the edge of the observable universe. And yet we cannot outrun a beam of light, not because we lack power, but because the idea itself doesn't belong to this universe. The limit is not technological, it is conceptual, and this forces us to rethink what it means to understand something. Understanding, in physics, does not mean making something feel comfortable. It means accepting that the universe has its own logic, independent of human intuition. The speed of light is one of the clearest examples of this. It is a fact that does not compromise. It does not explain itself in human terms. It simply is. And yet, from this single constraint, an entire universe unfolds. Stars burn in predictable ways. Particles interact. Time stretches. Space bends. Life finds a narrow path to exist. All of this, because information cannot move faster than a certain pace. It's almost poetic. The universe is not rushing. It is careful. Now imagine just for a moment that you could remove this limit. Imagine a universe where information travels instantly. No delay, no waiting, no distance. What would happen? The answer is uncomfortable. Such a universe would not be richer. It would be poorer. No causality, no structure, no meaningful sequence of events. In trying to make everything faster, you destroy the possibility of anything happening at all. This is the paradox Feynman loved. Limits are not always constraints. Sometimes they are the very things that make existence possible. Just as the rules of grammar allow language to exist, the speed of light allows reality to speak coherently. And here is where the story turns inward. You are not separate from this rule. Your thoughts, your memories, your awareness are all shaped by it. You are a process unfolding in time, limited by the same speed that limits stars and galaxies. You don't experience the universe all at once. You experience it as a sequence, moment by moment, because that is the only way experience can exist. So when you look up at the night sky, you are not seeing a frozen picture. You are seeing history layered across space. Some of that light began its journey before humans existed, some before Earth formed. The universe is always speaking from the past, and the speed of light decides how loudly and how slowly it speaks. Feynman never claimed this should make you feel satisfied. In fact, he warned against that feeling. Satisfaction is the enemy of curiosity. Instead, he invited people to sit with the discomfort, to accept that the deepest truths are not intuitive. That understanding does not erase mystery, it deepens it. So the next time you hear someone say, "Nothing can go faster than light," don't hear it as the end of a conversation. Hear it as the beginning. Ask yourself why the universe needs this limit. Ask what kind of reality requires such careful ordering. Ask what other assumptions you carry that only work because you live at slow speeds in a small corner of space. Because every time physics has shattered our common sense, it hasn't made the universe smaller. It has made it stranger, deeper, more honest. And perhaps the most important lesson is this: the universe is not obligated to make sense to us. We are obligated to learn how to listen. And the speed of light is one of the ways the universe quietly tells us how it works, without ever explaining itself at all. Silence follows that realization, and in that silence, curiosity survives.